Recording in progress.
In this video, we'll talk about binary and decimal conversion. How to convert a binary number to a decimal. How to convert a decimal number to binary. I hope you know what's a binary number. A binary it's binary it's 1 and 0. That's a binary 1 and 0. Decimal number, decimal number is 1, 2, 3, 4, 5, 6, 7. So 1 in decimal to 1 in binary. We have different types of bits in binary. We have 2 bits. We have 1 bit, 2 bit, 4 bit. Let me 3 bit, 3 bit, 4 bit, continuously. So bits is how many digits you can write your number in binary. How many digits you can write your number in binary. These are bits. Bits, the definition of bits is how many digits you can write your number in binary. So if I want to write 1 in 1 bit, it's 1. 1 in 2 bits, it's 0, 1. Remember, this is binary. Here is decimal. Decimal to binary. Binary, decimal is represented by a base 10, and binary is represented by base 2. When I say base 10 and base 2, let me put X. So it's like this. It's like this. To see a number is a decimal number. The X represents any number. Then there's a small number at the corner. That tells you it's a base, and it's a base 10. Base 10 is for decimal. Base 2 is for binary. Base 2 is for binary. So now I want to write 1 is from decimal. I can write it in 1 bit, 2 bits, 3 bits is going to be 0, 0, 1. 4 bits is going to be 0, 0, 0, 1. So this is 1 in 1 bit, 2 bits, 3 bits, 4 bits. I converted 1 to binary. So how do you convert a decimal number to a binary? How do you convert a decimal number to binary? How do you convert it? I'm using this method. This method is called a sum weight method. Sum weight method. So when you want to convert any number in decimal to binary, depends on the number you're converting. So let's convert 5 to binary and 15 to binary, 74 to binary, and 13, 17 to binary. I want to convert all these numbers. They're in decimal. I want to convert them to binary. So let's start with 5. I'm using the sum weight method. So always use the method is like this: 1, 2, 4, 8, 16, 32. 32, 64. So the method is like this. It's 1. You start with 1, then you say 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. 32 times 2 is 64. 64 times 2, 128. Continuously. The method, you start with 1, then you multiply 1 by 2. You multiply 1 by 2, it gives you the next number. You multiply that number by 2, it gives you another number. That's how we write the numbers of converting a decimal to binary. So we always multiply by 2. Why 2? Because the 2 is the base number of binary. So you multiply your number by 2 to get the next number. 1 times 2 is 2. 2 times 2 is 4. 4 times 2, 8. 8 times 2, 16. 16 times 2, 32. 32 times 2, 64. So now I want to convert 5 to binary. I don't know, maybe they say convert this number to binary and they didn't specify in how many bits. You don't know how many bits you should convert your number. How do we do that? How do we know how many bits should I write? What is the minimum bit of 5? What is the minimum bit of 15? What is the minimum bit of 74? What is the minimum bit of 30? How do we know the minimum bit of a number that I'm given or an unknown number? Since I want to convert 5 to binary and they didn't specify in how many bits. Remember, bits is the digits you can write that binary number. It's the numbers of digits that you can write your number in binary. Since I want to convert 5 to binary, I will check 1 is less than 5, 2 is less than 5, 4 is less than 5, 8 is greater than 5, 16 is greater than 5. So since 8 is the first number that is greater than 5, I will cut the other numbers. Then I'll be left with 8, 4, 2, 1. So I will check always your number that you're converting. You're converting your number that you are converting into binary. If you don't know how many bits you should write it, always this is what you do. You write this 1 up to 128, 256, 512, and so you will check that number is greater than how many numbers? Is greater than 1, is greater than 2, is greater than 5. I mean greater than 4, but it's less than 8. And since it's less than 8, then I will take 8 and other numbers I will discard them because they are still greater than 5. Therefore, I will say, what is 5? 5 is 4 plus 1. Here is 4, here is 1. So where the numbers are present, the numbers that form 5, you put ones. You put 1 underneath those numbers. And the one that they don't form 5, when you add them, the remaining ones, you will put zeros. The remaining ones, you put zeros. Therefore, this is 5 in binary. Therefore, 5 base 10, which is decimal in binary, is going to be 0, 1, 0, 1 base 2. 5 in binary, it's 0, 1, 0. Remember, there is something that's called LSB and MSB. LSB is least significant bit. MSB is most significant bit. Least significant bit, most significant bit. So that's how we convert a decimal number to binary. The number was 5. Converted to binary, it's 0, 1, 0, 1. See? So now let's convert 15 to binary. 15 to binary. 15 to binary. I don't know how many bits should I write. 15, 16, 32, 64. So I'll cancel the ones for 15. I want to convert 15 to binary. 15 is 8 plus 2 is 10. 4 plus 1 is 15. So 8 plus 2 is 10. 4 plus 1 is 15. So 15 is formed by 8 plus 4 plus 2 plus 1. Then here I will put 0. How many bits? Since 16 is the one that is greater than 15 and 32 and 64. Therefore, I will cancel the other numbers. Then I'll be left with only 16. So the minimum bits I can write 15 is 5 bits. So the way I convert, and the way I convert tells me how many bits should I write that number to be on a safe side. If I don't know how many bits should I write the number. So 15, I first check 15 is greater than 1, is greater than 2, greater than 4, greater than 8, then less than 16, less than 32, less than 64. So since it's less than 16, I take 16. The other numbers, you cancel them. Therefore, you add those numbers that you have. The ones that gives you 15, underneath you put 1, 1, 1, 1. The one that you didn't include it, the one that is not included when you add them to give you 15, you put 0 underneath that number. Therefore, that means 15 base 10 is equals to 1, 1, 1, 1. So 15 in binary is 1, 1, 1. Another example, let's convert 74 to binary. 74 to binary. 74 to binary. 128, 64, 32. So now 74 is greater than 70. 74 is greater than 64. That's why I add 128. So already I'm fine on 128 because 128 is greater than 74. Then the other numbers after 128, they're also greater than 74. So there's no need to add them. So 74, which numbers can form 74 here? There's only one type of numbers that can give you 74. There's no other numbers. The numbers that we'll pick here, that will give us 74. There is no other numbers that we can add in to give us 74. So this method is 100% accurate. There is no way you will go wrong with this method. You will always be right when you convert decimal number to binary. And it's very fast if you understand. So 74 is 64. If the number you include, if the number when you add it gives you 74, underneath you put a number, you put a 1, you put 1. So 64 plus 8 plus 2 is equals to 74. For 1, the remaining numbers you put zeros. The remaining numbers you put zeros. If you add 32, 16, 1, 128, they won't give you 74. Expect 64, 16, 2. I mean 64, 8, 2. It's only 2, 8, 64. Numbers that they can give you 74. There is no other numbers that can give you 74. Expect 64, 8, 2. So 74, the 10. The small 10 that I write is that one determines a base. So it tells you this number is in decimal form. Then the small 2, it tells you the number is in binary. So we don't need to write the decimal in words. Just use the 10. Therefore, 74, it's 0, 1, 0, 0, 1, 0, 1, 0. Therefore, that's how we converted 74 to binary. Therefore, let's convert 13 to binary. You can convert 0 up to, if you understand this method, you can convert 0 up to 15 by head. I can convert 0 up to 15 by head using this method of converting decimal number to binary. So 13, what is 13? 13, why I'm left with 16? Because 16 is the one that is greater than 13. So it's fine there. So 13, sorry, there's a 0 there. Sorry, I forgot to put the 0. The most significant bit numbers, if it's 0 or if you don't write it, is still fine. If you write it, if the most significant bit, it's 0. If you don't write it, it's fine. If you write it, it's fine because it don't affect. If you don't write it, it's fine. If you write it, it's still fine because it don't affect your number. But once you put the number on the least significant bit, it will affect your binary number. So it will change the value of your binary number. It's no longer going to be the number that you're converting. So what is 13? 13 is 8 plus 2 plus 1. Therefore, the ones that are remaining, you put zeros. 13 in decimal to binary is 0, 1, 0, 1, 1. That is 13. What is 17? 17, remember now I have 16. So 17 is greater than 16. I will have to add 32. I will have to add 32. I will have to add 32. Therefore, what is 17? 17 is 16 plus 1. Therefore, the other numbers, the remaining numbers, you put zeros. 17 in decimal is equals to 0, 1, 0, 0, 0, 1 in binary. Remember, the topic is about converting binary numbers to decimal and decimal numbers to binary. So now we converted our decimal numbers to binary. So now let's convert the decimal, the binary numbers to binary. So now let's go back. Let's go back. So I have 0, 1, 0, 1. I will take these numbers. We want to prove whether we are wrong or right. So I have 0, 1, 0. I want to convert it back to decimal. I want to convert back to decimal. So when you convert a binary number to decimal, what do you do? What do you do? You'll use 2. How are you going to use 2? So now I want to convert this number back to decimal number. Underneath that number, you will put 2 to the power 0 plus. Let me put it in this way. Let me put it in this way. So you start from the LSB here. You start from LSB. You say 2 to the power 0 plus 0. Let me do this. Let me do it in the manual way. So I will say 1 times 2 to power 0 plus 0 times 2 to power 1 plus 2 times 1 times 2 to power 2 plus 0 times 2 to power 3. So this one is the least, is this one. Then this 0 is this 0. And then this one is that one. And the last 0 is this last 0. So I put it in another way. I change the direction since now I'm converting back to decimal. But when you convert a binary number to decimal, you start from the LSB. Always the LSB is the first number counting from right to left. Is your LSB. So you say that number, you multiply by 2, and then you put 0 and on the exponent, you start 0, 1, 2, 3, 4, 5 continuously. So always is you multiply by 2 to power your number depending on the number of digits. So the 0, 1, 2, 3 is the number of digits. 0, that it means it's the first digits, 1 second digits, 2 third digits, 3 fourth digits. So press this on the calculator, it's going to give you 5. It's going to give you 5. So now let's convert 0, 1, 1, 1, 1. Always it's going to be, you start from the LSB, 1 times 2 to power 0 plus 1 times 2 to power 1 plus 1 times 2 to power 2 plus 1 times 2 to power 3 plus 0 times 2 to power 4. If you press this on a calculator, you will get 15. You see, so we are going back, we are converting binary numbers back to decimal numbers. back to decimal numbers. So just put the 10 to show this is a decimal number. You can do it for 13, for 17, and 74. You will see it's going to give you these decimal numbers. So that's how we convert a binary number to decimal and decimal number to binary. Let's do another example of binary conversion to decimal. So let's convert, let me give you numbers that you need to convert to binary. Let's convert these numbers: 7, 4, 39. Just pick a random numbers: 30, 34, 49. Let's convert them to binary. Let's convert these numbers to binary. So 7, always use that method. 1 times 2, 2 times 2, 4 times 2, 8 times 2, 16 times 2, 32 times 2, 64 times 2. See? So always use this method. So I want to convert 7. 7 is from decimal to binary. What form 7? 7 can be from, remember, 8 is greater than 7. So these numbers, I will ignore them for now, since 7 is only fall under these numbers. So 7, what can form 7 from these numbers? 7 can be formed by adding 4 plus 2 plus 1. Therefore, the one that you don't include, the one that you don't add, you don't include when you add your numbers, you put 0. The remaining number always put 0. So that means 7 is equals to 0, 1, 1, 1 in binary. 7 from decimal to binary, it's 0, 1, 1, 1. 4, let's convert 4. Let's convert 4. Again, for 4, I will still ignore these numbers since 8 is the one that is greater than 4. So what is 4 in binary? I have 4 on my sequence. There's already 4 on my sequence. So I'll just put 1 on my sequence. And the remaining numbers, just put zeros underneath. Then 4 is equals to 0, 1, 0, 0 in binary. 39, let's check 39. So now since 39 is greater than 16, greater than 32, but less than 34, that means I will only discard 128. I will ignore 128. I will ignore 128. So what is 39? 39 is 32 plus 4 plus 2 plus 1. 39 is 32 plus 4, 36 plus 2, 38 plus 1, 39. The remaining numbers on your sequence, underneath you put 0. The remaining numbers on a sequence, underneath you put zeros. So 39 in decimal is equals to 0, 1, 0, 0, 1, 1, 1 in binary. 34 in decimal is equals to what in binary? Again, 34 is less than 64. Still, I will ignore 128. Still, I will ignore 128. So let's see what is 34 in binary. 34 can be formed by adding 32 plus 2. Then on a sequence, I have these numbers. The remaining ones, always put zeros. Always you put zeros. You always put zeros. So what is 34 in binary? 34 in binary is 0, 1, 0, 0, 0, 1, 0. Remember, this is LSB. This part is LSB. It's LSB. So this part always is going to be MSB. MSB is where your numbers end, and LSB is where you start writing your number in binary. Where 49, still 49, it's less than 64. So on this sequence, I'm going to ignore 128. 128 is going to be ignored on that sequence. I don't know how many bits will write the number. So the greater number for the number that I'm converting to binary determines how many bits I should write my number in binary. So what can be formed to get 49? 49 is equals to 32. 49 is equals to 32 plus 16 plus 1. The remaining ones on my sequence, I'll put zeros underneath. So 39 is equals to 0, 1, 1, 0, 0, 0, 1 in binary. So you can also convert a binary number to decimal using this method. You can do both. Can convert back, can convert it going back and going forward. So this is decimal numbers. I converted them to binary. So now let's have a binary numbers and convert them back to decimal. So I'll just write down a random binary numbers. I want to show you how is this method, how fast can use this method and how easy is this method. So now let's convert a binary numbers to decimal. Binary numbers to decimal. Sorry, it's 128 here. We have 0, 0, 1, 0, 1, 1. Binary 1, 0, 0, 1, 1, 0, 1, 0. Binary 1, 0, 0, 0, 0, 0, 1. Binary. These two stand for base. Base, which is determines the type of number you wrote. So in digits, these two tells you your number is in binary format. So I can't say it's 100 and what. It's a binary number. 1, 1, 0, 1, 1, 0, 1, 0, 0. 1, 0, 1, 0, 1, 0, 1, 0. So let's convert these numbers to decimal. So how to use this method to convert a binary number to decimal? The way your number it is, make sure you start from the LSB always. So from the LSB, I will write the numbers. I will write the binary numbers. From the LSB, it's 1. You align them with your sequence. You align them with your sequence. So it's 1, 1, 1, 0. Make sure you don't skip a number. 1, 1, 0, 1, 0, 0. So what is this number in decimal? What is this number in decimal? I will rewrite the number again here. So this number in decimal, you will just add the numbers on your sequence, which is 1 plus 2, 1 plus 2 plus 4 plus 16. So the number is 23 in decimal. 0, 0, 1, 0, 1, 1, 1 is 23 in decimal. So what about 1, 0, 0, 1, 1, 0, 1, 0? So we always, okay, repeat the same thing. Start from the LSB. First number 0, 1, 0, 1, 1, 0, 0, 1. So you add your numbers where you add numbers that they are aligned with ones. The one that's aligned with 1, 1, 1, 1, you add them. 128 plus 16 plus 8 plus 2. The number is equals to 154. So this number is equals to 154. And that one is equals to 23. And what is this number in decimal? Okay, number is 1 0 0. How many 0? 2 4 5 0 0 0 2 4 5. How many 0 to 5? Then 1. So just put 0 here. Doesn't mean anything. So the ones, they are aligned with 1 1 1 on a sequence. You add them. So that means this number is equal to 65. So this number in binary is equal to 65. You can also verify this using a calculator. Let's go to another number. So the number is 0 0 0 0 1 0 1 1 0 1 1. So 128 times 2 is 256. So I have to increase my sequence. Just multiply the last number by 2. Then it's 256. Therefore, since I don't have a space, I added 1 is aligned with 256. Therefore, the ones that are aligned with 1 1 1, you add them. 4 plus 16 plus 32 plus 128 plus 256. So this number is equals to 436 by 10. Let's see again the last one. Remember, we're converting from binary to decimal. The last one is 0 1 0 1 0 1 0 1 0 1 0 1 0 1 0 1 1 2 3 4 1 2 3 4. So 28 plus 32 plus 8 plus 2. 128 plus 32 plus 8 plus 2 is equals to 170. So the last number is equals to 170 in decimal. So that's how we convert decimal numbers to, that's how we convert binary numbers back to decimal using the same method of binary, sequence, decimal sequence.